Welcome to this Telit Cinterion webinar, Optimizing Connectivity for Mission Critical Applications. I'm Amanda Flink, the Head of Global Events here at Telit Cinterion, and I will be moderating today's event. Joining me today is Jose Sanchez, our Senior Director of Product Management for IoT Connectivity. Hi, Jose. Thanks for joining us.
Hi, Amanda. Hi, everybody.
Just before I hand it over to Jose to start our presentation, I do have just a few quick reminders for our audience. We will have time to answer some questions at the end of our presentation here today. You can simply submit a question by posting in the questions box, which is located near the bottom of your screen. Also, please take a few minutes to check out the resources section for some additional information on our topic today. And finally, we will send out that replay link to all attendees at the conclusion of the webinar. So if you'd like to share this with colleagues or maybe rewatch a certain section, that will be in your inbox in the coming days. And with that, Jose, I will hand it to you to start our presentation today.
Thank you, Amanda, and welcome everyone to this webinar. And as the title says, we're talking about connectivity, IoT connectivity, and optimization of IoT connectivity. We'll be speaking about a specific class of applications which we call mission critical applications that need utmost uptime and throughout their lifetime. So let's, without further ado, let's start the presentation and move on with a little bit of context on what is actually mission critical in the context of IoT. So in the context of IoT, mission critical doesn't have a very concrete or specific definition. It really depends on your perspective of the business. There are obviously applications that are considered by the majority of the market as mission critical, like monitoring of critical infrastructure, for instance, energy and utility applications, monitoring of oil and gas infrastructure, for instance, pipeline monitoring, smart city applications, and other applications, obviously, like first responders, public safety applications. Other critical applications can be smart buildings, security systems, even healthcare systems, or even payment systems, right? So it really all depends on the definition. Some applications cannot really afford any kind of service interruptions, and that's the critical point. That's the important point. You need to look at what level of service interruption your application can afford. Are there any severe safety, security, or financial impact when the application is down? So the impact of downtime is essential to look at what is a mission critical or critical IoT application. We find this kind of applications in many sectors, right? As we said before, and this segment is evolving now more than ever. There's a lot of buzz in the market about this kind of applications and how to actually improve in general the availability of cellular for IoT. So how to make, in the end of the day, reduce risk of downtime and improve customer experience, improve return on investment for companies, enterprises that are utilizing IoT, cellular IoT technology in particular. So this means that application implementers, companies developing IoT applications need to understand and address the specific needs of this IoT critical applications in the context, a specific context of cellular communications. There are specific technologies that can be used in order to, improve the availability, resilience, and in turn to deliver the expected quality of service in this mission critical context. So what are technologies that can be used in the mission critical context, right? So what are the technologies that implementers have at hand to implement an application that complies to the specifications of the mission critical space and market? So how can you actually deliver the experience you need to your customers? So obviously there are many technologies. There are also processes that can be implemented to deliver mission critical applications. But when we look at the technologies, we can look at different areas. For instance, we can look at device or hardware technology. We can look at network technology. We can look at cloud technologies. We can look at even security technologies. When we look at devices, we see that many developments have happened in the last 15, 20 years that go always in the direction of improving the resilience, improving the reliability of IoT applications. We can talk about MIMO systems, antenna systems. We can talk about redundancy in terms of hardware, redundancy, using multiple MCUs in parallel, using redundancy at the cellular modem layer. So having multiple modems, using redundancy at the SIM card level, having multiple SIMs. We have technologies such as dual SIM, which are in place since already many years. We have also software technologies such as smart agents and connection managers that are used to improve the reliability of applications. On the network side, we find technologies that such as network slicing, for instance. I mean, 5G has introduced the concept of network slicing, so applying specific slices to deliver a specific quality of service to specific customers is an option to improve reliability. Using, for instance, even private deployments, private network deployments in applications that can afford or can support a private network deployment combined with even public network for a hybrid deployment is also an option. Using technologies such as roaming, for instance, being able to roam on a particular network or groups of networks and being able to roam them on more than one network at a national level allows applications to be resilient to changes and outages. Multi-IMSI technologies, right? So having multiple identities on a SIM card and allowing identities to be shifted or switched according to the application needs. We will speak to those SIM-related technologies later on during today's presentation. Using eSIM, for instance, and many other possibilities. On the cloud side, we see, for instance, technologies that are very mature, such as using geo redundancy solutions, microservices architectures, auto-scaling, load balancing, high availability databases, etc., etc. Down to having disaster recovery plans for cloud services in place. So all of this is state of the art today, and it's being used to improve the availability of IoT applications. But let's not forget security, right? So enabling that the application is secure means also making it available, because as part of the security principles, availability is one of the key elements of application security, and therefore availability means reliability and means ability to deliver mission critical applications and or deliver services for mission critical applications. So the more security you implement, the safer it is for you application in the field. Therefore, the higher the availability of the application. Things such as performing pen testing, implementing hardware root of trust, for instance, right? Instead of a software root of trust. Implementing firmware update mechanisms, firmware over-the-air update mechanisms, and last but not least, complying to cybersecurity regulations. All of these are technologies that can be used to improve the reliability of IoT applications, and these belong to the technology option space that implementers have at their disposal. But in this presentation, we want to talk about eSIM solutions and eSIM technology, and how eSIM technology is making its way to the mainstream, and it's finding more and more uses in IoT. So eSIM has been traditionally used as a technology in since about 10, 12 years, when the M2M standard was created, and was used in specifically or mostly in automotive and other applications in IoT. But now it's finding its way into the mainstream with the creation of new IoT eSIM specifications, and this means that applications will find it easier to utilize eSIM technology for different purposes. If we look at the innovation or the hype cycle, we have technologies that are rather on the maturity side of things, such as firmware update, over-the-air updates, or global roaming, for instance, being technology that has been utilized for years. Multi-IMSI technology, also solutions that have been used already for 5-10 years, right? But we see that at least we see eSIM technology as becoming mature after being hyped for a while, mature for use in massive use in IoT, and not just to deliver the ability to replace physical SIM card exchanges, but also to deliver quality of service. And how this can be done, we will deep dive a little bit more in the next slides during my presentation. So all in all, the evolution of IoT technology and IoT cellular connectivity starts, from let's say 10-15 years ago, where the most common solution was based on IoT roaming or global roaming, evolved into using eSIM technologies, SGP.02 eSIM technologies, and Multi-IMSI technologies, and now it's evolving to using SGP.32 technology, which is the newest IoT eSIM standard, and allowing technologies on top of that to dynamically, change or allow the device to react in case of connectivity outages. So the use of eSIM technology allows to provide better resilience, better availability, and in turn, deliver quality of service, the quality of service that is needed by mission-critical applications. So we see the evolution of these coming and moving forward also in the future with the addition of QoS insights, right? So if you combine QoS insights with eSIM technology, you have a very promising, evolution that is to come in the next years. Supported by smart edge technology, agents, and smart cloud technology, probably supported by AI technologies, both at the cloud and at the edge. Now, let's go back to the eSIM topic, right? So how does eSIM technology work, and how is it used in the mission-critical context? Before that, let's take a small step back for a second and remind ourselves of what is actually eSIM technology and what is it used for. So an eSIM or a EUICC is a EUICC or a SIM card that supports over-the-air remote SIM provisioning, right? So it's basically a programmable SIM card. And an eSIM can have several form factors. So an eSIM is not a solderable SIM. It can be also a plastic SIM in the context of, any kind of application. You have eSIMs today as plastic SIMs or pluggable SIMs, or as solderable SIMs, and available in multiple form factors. Remote SIM provisioning is the ability to download over the air the required MNO profile in line with GSMA specifications. And this is essential because the difference that resides in the fact that eSIM technology is standard and allows interoperability, right? The platform used to perform these services is called a subscription management platform, right? So SIM, the eSIM typically comes in the IoT space always linked with a server or a platform, and this platform allows the remote installation of SIM profiles over there. Each SIM profile belonging to a specific connectivity service provider, and multiple of these SIM profiles can be combined in a single SIM card. Now let's look at how SIM technology has evolved in order to help implementers provide resilience for their applications. So we've said it a couple of times earlier today. So roaming SIMs allow access to multiple networks on a single IMSI or a single identity. This is based on direct or indirect roaming agreements, either through IMSI donors who are aggregators of contracts or agreements with operators worldwide, or indirect operator agreements with operators worldwide. Next, dual SIM solutions, right? So here the device implementers try to improve the reliability of applications and overcome limitations given by the fact that some networks might not be available at specific times. They might be downtimes. So the dual SIM solution allows the device to or use a failover configuration and switch SIM cards automatically in case of outage. So in this case, 2 or even more physical SIMs are connected to a single device. You can achieve redundancy, but this solution doesn't allow over-the-air management of the profile. So if you want to change providers, you have to swap cards. And all in all, it has higher cost than a single SIM solution, right? Then we move to multi-IMSI solutions. In the multi-IMSI solutions, a single SIM card has 2 credentials, or 2 or more credentials, right? The credentials, we call them in the cellular space, IoT cellular space, IMSIs, right? So the IMSIs are used to identify a SIM card against a specific network, and that allows access to the internet through that operator's network. So there is a certain degree of redundancy that can be achieved here. Typically, these solutions are not really developed using an open standard, so you cannot combine solutions from different vendors, but it's been proven a very practical solution, which is actually deployed by most IoT MVNOs already today. So if you're using an IoT MVNO SIM card today, higher are the chances that you're using behind the scenes a multi-IMSI solution. The last evolution, which we're going to focus on during the rest of the presentation, is the eSIM, right? We call this here eSIM multi-profile because an eSIM can support multiple MNO profiles. These are fully standardized. They are and can be remotely upgraded. 2 or more, the limit, there's no specific limit to the number of profiles that can be used in a single eSIM. You can have as many profiles as the eSIM memory supports. You can achieve redundancy at an attractive cost point, and you have lifecycle management already built in. So you can actually modify remotely the profiles that are present on the SIM card, and you can install new profiles, remove profiles, etc. And multi-vendor deployments are possible because the solution is standardized and interoperable. So let's deep dive into the eSIM multi-profile, right? The eSIM multi-profile solution allows, for instance, to do things like we're showing in this slide. The eSIM is pre-flashed with one or multiple profiles out of the factory. It could be a single profile out of the factory. Then the connectivity management platform users, they're basically the platform provided by the IoT MVNO, define business rules for coverage, cost, quality of service, etc. So based on what is the priority for your application, you can define business rules and can then allow the CMP platform to manage that profile remotely and automatically based on the rules that you have already set up in advance. With this, you can achieve application resilience. You can install 2 profiles on the SIM card, utilize what's called the so-called fallback feature to automatically switch the profiles on the SIM. So whenever a network becomes unavailable, you can automatically switch to another profile, which is like switching physically another SIM card, right? So when you in the past used dual SIM configurations, you were physically switching the SIM card used. Here you are virtually or by software switching the SIM card used automatically. This is what we call fallback, and this can help applications which achieve resilience, and it can help deliver the quality of service needed for mission-critical applications. So one of the key aspects of this new eSIM technology is that there is a standard, it's interoperable, and this standard has been designed with applications in mind that are not just IoT, but they have specific characteristics, right? So they are designed with applications in mind that need to be battery efficient, that need to be always connected. And as such, certain features were developed in this specification to allow applications to deliver always-on connectivity. For instance, you should watch, and I recommend you to read the GSMA specification. For instance, profile fallback. It's a feature that allows the SIM card to automatically switch to alternative profiles in no service limited service conditions. So the SIM card automatically basically switches the profile in order to remain connected, and the device will be able to remain connected even in situations where one of the networks, the network to which the device is attached, is down for a certain time, or coverage is lost. Local profile management, so that allows intelligent device logic to be developed, to manage SIM profiles locally. This is a feature which is not currently supported. We expect it, it will be supported at some point in the future, probably in 2026. This will allow smarter device logic to drive the SIM provisioning process, so that even if the device is disconnected, application implementers can implement an agent that automatically, or based on device KPIs, tries to maintain always-on connectivity. Multiple enable profiles is a feature already available for consumer markets, for the consumer eSIM, and this will allow multiple SIM profiles to be active at the same time, which would eventually allow faster switching between profiles to achieve always-on connectivity for mission-critical applications. Well, let's switch gears a little bit. Our portfolio in Telit Cinterion, when we talk about global connectivity for critical applications, we talk about next global connectivity. We are, as an IoT, a full IoT MVNO, have solutions that can deliver value to critical applications in the IoT sector, and for this, utilize the latest eSIM technology, as we described earlier. The main pillars of our portfolio are global coverage, extended roaming, and profile localization in countries with permanent roaming restrictions. We utilize global roaming technology, we utilize Multi-IMSI technology, but also eSIM technology for seamless connectivity worldwide. Resilience is another main pillar of our value proposition, where we deliver always-on connectivity. We utilize Multi-IMSI technologies to do that, but also fallback, eSIM fallback technology to maximize uptime and business continuity. And last but not least, obviously, without top-notch support, this wouldn't be possible. Our plans are supported by a global team that provides 24/7 support around the clock with a specific network operations center that is there to support mission critical applications or critical applications wherever they are and at any point of time. So these three pillars are essential, and what we have actually done to deliver value to mission critical applications will be described in the next couple of slides. First of all, the next e-profile. So our e-profiles are virtual profiles that can be downloaded from a server. Server is called an SMTP Plus server, as defined by GSMA specification. We provide these profiles in the form of activation codes or QR codes, as defined by the GSMA specification. So our profiles are fully compliant with GSMA specification and can be downloaded into a GSMA compliant eSIM. So this is the first pillar of our offering, and that supports our eSIM strategy. E-profiles are essential. We have a portfolio of e-profiles, and they can be downloaded into any device that has a compliant SIM. Later on, once the profile is downloaded into the IoT device, it is managed through the Telit Cinterion Next Connectivity Management Platform, or CNP. The second pillar is what we call eSIM multi-profile. The eSIM multi-profile is an eSIM, a global connectivity solution that is running on an eSIM that provides global coverage, resilient connectivity, the ability to do profile localization in countries with permanent roaming restrictions, or the ability to bring your own connectivity, even in case you already have existing agreements. You can bring your own connectivity into the mix. So what are the benefits? We provide localization, so avoiding permanent roaming, resilient always-on connectivity, because you can bring in more than 2 e-profiles onto the card and then use the fallback, eSIM fallback technology to maintain connectivity, even if one of the profiles is, doesn't provide you coverage at a given time. This gives you an extra level of assurance that your device will be always connected. And as mentioned earlier, last but not least, you can bring your own carrier connectivity agreements. We can implement multi-core configurations depending on the customer requirements. And as said before, this service unlocks access to a catalog of e-profiles. Our e-profiles can be used and combined in order to achieve optimal coverage and maximum uptime. The eSIM multi-profile works like I mentioned before. Several profiles are available in our catalog, and they are delivered along with our eSIMs to you. Our eSIMs are available in different form factors and plastic, solderable, etc. And you access our connectivity management platform, and you are in control. Our customers define the business rules that will govern the management of those profiles based on your preferences. And last but not least, when the device goes into the field, the system, the CNP, will detect any changes in the device configuration and, for instance, the country of operation or the situation, the coverage situation, and will issue commands to the SIM card in order to achieve the target. So with this, we deliver top-notch technology, the latest eSIM technology for any kind of application. Specifically, we believe we can deliver the quality of service needed by critical IoT applications, and this combined with our multi-IMSI and global roaming portfolios give really an extremely comprehensive portfolio to all of our customers. In order to finalize, I'll give you just a few notes about Telit Cinterion connectivity and try to summarize what we have discussed today. So Telit Cinterion provides global connectivity on a single SIM with the ability to remotely manage connectivity profiles through our connectivity management platform. By the way, Telit Cinterion is the top Western module vendor, and we embed connectivity into our hardware, into our modules, in order to make the experience for our hardware customers seamless. Our management tools allow to set the rules and the targets that you need in order to achieve, in this case, it could be resilience, always on connectivity, the lowest cost, or any other KPI that you can imagine. And we run this up by providing a global support 24/7 to our IoT customers. So with this, I'm finalizing today's presentation, and I'll be happy to answer some questions now in the Q&A session. Thanks a lot.
Thanks, Jose. Audience, just real quick before we get to those questions, I am going to drop a poll on your screen. If you would like to have one of our experts contact you, maybe you have a really specific question to your application, please just respond here on the poll and we will have somebody reach out to you to set up a meeting. We do have time for some questions, and there's still time to ask, so please feel free to submit using that box at the bottom of your screen. Jose, we've gotten just a couple here, so let me just dive in. The first one, what is the key difference between SGP.22 and SGP.32, and why does it matter?
Yeah, it's easy to get confused between these two, Amanda. By the way, these two specifications are aimed at two different segments of the market. The GSMA SGP.21 or 22 specification is aimed at the consumer segment, and the GSMA SGP.31 or 32 is aimed at the IoT segment. So now the IoT specification was just recently released, right, earlier this year. So it's now finding its way into the market. All IoT companies are running to certify the solutions according to GSMA. The main difference between these two specifications is the fact that from the ground up, SGP.32 has been designed to be remotely managed. So that means that it only makes sense with a remote server called the eIM, and that combination allows IoT applications that don't have a local user interface to become remotely managed. Whereas the SGP.22 is and was designed originally to be locally managed by a user, which is in front of the device. That's the main difference, and that's why it matters.
Thank you. Our next question here asks, do you have any real-world examples of reduced downtime or even cost savings using the next eSIM?
Yeah, I mean, we have many user scenarios where eSIM is being utilized today. For instance, if you look at applications such as critical infrastructure monitoring, I'm thinking of utilities. There are situations, for instance, such as the installation of the meter or the installation of the sensor in the field that are critical. You cannot lose time. With eSIM technology, you can install, more than one profile in the SIM, so that if, for whatever reason there is no coverage with the standard or the default profile, you can quickly, install or switch to a second profile. That allows efficiency because it shortens the installation time, whereas meters or sensors in the field might need to be replaced. The cost of replacement is usually very high.
Okay, great. The next question I received: how would this eSIM support my application, for example, in healthcare, where my devices are often remote and uptime is critical?
Yeah, so if they are remote and you don't have access to the device, eSIM is the only, let's say, widely adopted or accepted technology that allows you to remotely manage the SIM card over the air. So it's really the only technology that is interoperable and that is supported by global operators worldwide. So how does it help? Well, we more or less mentioned it earlier, right? So it allows to have multiple SIMs in a SIM card, so multiple virtual SIMs inside a SIM card, so that if one is not giving you the coverage you need, you can quickly and swiftly change to the next one. And you could do that in order to achieve whatever KPIs your application, or are relevant for your application. That is how eSIM technology allows to achieve, uptime.
Great. I think we will take just one more here. And this question asks, is profile switching automated, or can it be controlled manually through APIs or platforms?
Good question. I would say it's both. So profile switching can be automated. As we discussed earlier, our eSIM multi-profile solution already implements the automation mechanisms in the CMP that allow to react in case of changes. For instance, device going into a no coverage situation, device going into a different country, etc., etc. But there are also ways to or manually control this process via the CMP portal or our REST APIs. So you actually have the choice. For large-scale deployments, automation is essential. But there might be cases where manual intervention on some specific units can be of benefit. So you can actually do both.
Great, thank you. Jose, I really appreciate your time today. Audience, again, check out those resources in the resources section here for some additional information. This replay link will be sent to your inboxes. And we really appreciate you joining us.
Yeah, thanks for joining today. Thank you.
Have a good one.
Bye-bye.